Hey everyone, welcome back. Today we're tackling a question I get asked all the time by people looking to get into the precast business. How much land do I actually need to start my factory? If you've been searching online, you've probably seen answers ranging from you need 2 acres to 20 acres, and it's super confusing. So I've put together a small presentation to demystify this completely. I'm going to keep it simple, no complex engineering jargon, just the practical stuff you need to know so you don't buy the wrong piece of land. So let's jump into it. Alright, this is what we're covering today. How much land is actually required to start a precast factory? We're going to look into the practical, no nonsense answers. Whether you're a developer or an entrepreneur, this guide is going to be saving you a lot of headache. Here is the big confusion. Everyone starts with the wrong question. How many acres do I need? You see all these different numbers floating around, 7 acres, 10 acres, maybe 2. There's a huge myth out there that you need standard 5 to 10 acres to get even started. This is not true. The reality is that land requirement isn't a fixed number. It's a variable and it changes. It changes based on what you want to produce. The problem with most online advice is that it ignores your specific plan, like whether you're making walls or hollow core slabs or boundary walls, or how much automation you're going to be using. So let's stop guessing. So if you can't just guess a number, what actually decides the size? It comes down to 4 points or 4 inputs. First, production capacity. How many square meters are you going to be producing every year? Second, the product mix. Are you making wall panels? Are you making boundary walls? Are you making hollow core slabs? They take up different amounts of space. And the third, storage philosophy. This is huge. Do you need to store items for 10 days or 5 months? And finally, technology level. Are you going manual or automated? These 4 things combined determine your land footprint. It's not magic. It's just math based on these choices. Let's look at some real examples. Tier 1, minimum viable factory. This is for startups out there. Maybe you are just producing a limited range of things like floor slabs or beams. For this, you are looking at an output of about 40,000 square meters a year. Here is the surprise. You only need about 4,500 square meters of land. And this is roughly 1 to 1.1 acres. You don't need a massive complex. You can operate with maybe 9 people and a simple shed or even an open-air setup. So don't let anyone tell you that you need 10 acres to just start. Now we step it up to Tier 2, the automated or medium-scale plant. This is for established developers who need a wider range of products. You're producing way more, maybe up to 800,000 square meters a year. For this, you need about 2.5 to 5 acres. That's 10,000 to 20,000 square meters. The key insight here is that when you add automation, you actually need less labor, but you need more organized circulation space. You need a proper covered factory building and room for automated logistics to move things around. This is the comprehensive integrated yard. We are talking about infrastructure majors or city-scale developers. You are making everything. Walls, slabs, beams, columns. For this level of integrated system, you need 17 to 25 acres. 70,000 to 100,000 square meters, that is. You can see it in the layout here. You need distinct bays for standard parts and special parts. It's a massive operation, but remember, this is only if you're trying to build an entire city or a metro line. The hidden land eater. This is probably the most important slide on this whole deck. We call it the hidden land eater. Here is an insight. Storage often occupies up to 77% of your total land. People think that the factory building is the big part. It's not. The production area is only about 23%. The rest is just storage and logistics. The rule of thumb, plan for a minimum of 10-day buffer for finished goods. But be careful, if you're doing heavy infrastructure like tunnels, you might need a 5-month buffer, which will eat up your land fast. Let's talk about how machine choices can change your land needs. You have 2 choices, horizontal or vertical. Horizontal tech like tilting tables is great and versatile, but it's space hungry. Vertical tech like battery molds is amazing for saving space. You can make 10 panels a day in a tiny footprint. So, if you have limited land, you must choose vertical casting technology. It's the only way to fit high production into small spaces. There is one special case, hollow core slabs. These are made on long casting beds that are 150 meter long, and these can vary from 50, 60, 100 to 150. The longer the line, the better the efficiency. And that's why 150 is the ideal length that people recommend, or even machine manufacturers recommend. The implication here is that you don't need just area, you need length. You need a plot of land shaped correctly to fit these 150 meter lines. If you want to produce 4,500 square meters a day, you need 6 of these beds side by side. Plus, you need room at the ends of these machines to turn around. So shape matters. What happens if you try to squeeze into a plot that's too small? It's not just tight, it's expensive. You end up with double handling, moving stock A just to get to stock B. That wastes crane time and money. You get crane clashes where zones overlap and slow everything down. And worst of all, logistics fail. Trucks need 10 to 15 meters just to turn. If your roads are too narrow, your production literally halts because you can't get the product out. On the flip side, what if you buy too much land? Dead capital kills your ROI. Money tied up in empty acres is money you can't spend on better machinery. Plus, site prep costs like grading, drainage, fencing for 25 acres is huge. Sometimes a massive site just masks a bad layout. You get lazy with the design just because you have space. Remember, land is an asset, but unused land is a liability. This is the economic distance rule. Precast is heavy. Transport costs will eat your margins alive if you aren't careful. The sweet spot is being 100 to 300 kilometers from your project. Here is the trade-off. You could buy 10 acres really cheap if it's 500 kilometers away, but your logistics cost will be insane. It is often better to buy just 5 acres that are only 50 kilometers away. The land costs more, but you save a fortune on transport. So instead of asking how many acres, here are the right questions. What is the market demand? What technology am I using? How much storage buffer do I need? And if you answer those, the result is a scientific land requirement. It's a calculated number, not a guess. This is just a visual to show you how we map the footprint. We look at everything: production, warehousing, logistics, loops. It's like a puzzle. You have to fit the pieces together perfectly to optimize the capacity. I want to hammer this point home. The shed is not the factory. Look at this chart. The production hall is only 30% of the space. The other 70% is the storage yard, logistics, loops, curing areas, and offices. Your land requirements are driven more by inventory management, where you put the finished stuff, is what I mean, than your actual manufacturing process. So don't just count the acres, check the geometry. Shape matters as much as size. You have a 5-acre plot, but if it's a weird triangle or too short, you simply cannot fit those 150 long hollow core lines. You also need to ensure that you have the 10 to 15 meter road width for trucks. Also look at the shape before you buy. So let's recap the bands of tires with a focus on what is feasible. So band 1 is 1.5 acres, feasible for boundary walls, simple slabs, lintels. So it's not feasible for those complex infrastructure projects or hollow core slabs. You will not have the room for that. Band 2, this is the generalist. So this is around 5 acres. Here hollow core slabs become more feasible because you have the length. You can do structural frames, beams, columns, and this setup usually requires a covered hall and gantry cranes. This is band 3, which is the integrated hub, 15 to 25 acres plus. This is where you can do massive infrastructure projects like metro tunnels. You have space for multiple bays and massive buffers for storage that can go up to more than 5 months. This is for total precast buildings. However, there's a small nuance here. In band 2, in the 5 acres, you can also do a complete building. It's just that instead of finishing it in 6 months, you might take a year. So you can slow down and do all your projects even in band 2. The sweet spot is the band 2, and that's the the factory size that I like. So here's a quick cheat sheet, a feasibility matrix. You can see clearly if you do not do metro segments, band 1 and band 2 are in the red zone. Don't attempt it. Logistics will choke your profitability. You need band 3 for that. So it's not just about the area, it's about the topography. Is it flat? If the slope is more than 5%, cranes cannot operate safely. Soil stability, precast is heavy. So if the soil is weak, your stacks of product will sink or tilt. Utilities, do you have enough power and water? So remember this quote, cheap land becomes expensive if you have to drive piles just to store inventory. So this is a strategic choice you have to make. Automation versus, land. Option A is vertical battery molds, high initial cost, which is capex, but small footprint. You save on land. And option B is horizontal casting, low initial cost, but huge footprint. You pay more for land. Basically, land savings is equal to increased investment in technology. You have to balance that budget. A quick note on heavy infrastructure and tunneling. Here, inventory defines the facility. You need a 5-month buffer stock because you can never ever let the tunnel boring machine wait for a segment. So a 30-acre facility might only have a 10-acre production space. The rest is just going to be storage. So infrastructure is a logistics game. So validate value before you buy. Check commercial and technical feasibility. Ensure you can build the factory, which is execution. Ensure you can deliver the product. And of course, we don't guess. We model the ROI from the raw drawings before we even look at the land deed. And factory layout and operational planning. You need a workflow design that is seamless, from batching plant to production to curing to storage, finishing, dispatch. Every time you touch the product, it costs money. You want a plan that minimizes internal logistics costs. Financial modeling and ROI. Know your numbers before you spend. You need to look at your capex strategy and your operational economics. Are you using an Indian model, a Chinese model, or a European model? You need a precise break-even analysis so there is no financial ambiguity. So here is the golden rule of planning. Start with the market, not the map. Define your product mix, calculate your inventory buffer, determine your geometry, then select the land. Don't buy 10 acres just because it's cheap. Buy the right size for your product. This is where Modular Pulse comes in. We help you calculate land based on output goals. We optimize the factory layout to minimize travel distance. We also do the master planning so you're ready for the expansion tomorrow. We align your land costs with your ROI. If you want to know exactly how much land your specific precast factory needs, Modular Pulse can help you. Alright? So contact us before you buy. I hope this cleared up the confusion on land requirements. It's not a guessing game, it's a science. I also want to let you know that we have a report on this specific topic, and you can access that report for free, and there's a link in the bio below. You can click on that and download it for yourself. Thank you very much, and I'll see you in the next video. Thanks for watching.